We're now in a position to sort of almost answer some questions. So just to sort of finish off what we had before, we just heard that expansions are allowed to be infinite, however, they must converge, and that has some restriction about x. So let's have a look at this case here. It's sort of done for us already, but it says, when will this be valid? Well, what we're going to say then is we're going to say that the term that sort of fits the x position, this part here, the absolute value of this has to be less than 1. That was the restriction from before. Okay, so when is this going to be the case? Well, it's going to be the case, if I sort of work backwards, that minus 1 and 1, if I undo the modulus sign, it's going to be 3x, and then I can divide both sides by 3. It's going to be when this condition is fulfilled. Okay? Or a neater way of saying that is you could just say that the absolute value of x is less than a third. Okay? So the way to apply it in questions, and you are expected to do this, as we'll see in a moment, you find the part that occupies the x position, okay, and you say that the absolute value of this, as a shortcut if you like, you can sort of just ignore the negative really when you use the absolute, is less than 1. So let me just show you. An alternative way to sort of go about it is this. Okay, so this is the condition on x based on what we saw last time about when the expansion is valid. And we can apply it quickly to some quick fire examples here. So the top example, I know that the modulus of 2x has to be less than 1. So the modulus of x is less than a half. Okay, if you know what to do there and you're sort of happy with the second part has to be less than 1, okay, in absolute terms, it's quite an easy mark to get. Similarly, if we do modulus of minus x is less than 1, okay, so we can just say here, well, really, that's the answer, isn't it? Okay, and sometimes if we have something like a quarter x, the modulus of a quarter x is less than 1. Multiply both sides by 4, and you will get something like this. Okay, which is a common answer. So that's what you need to do. Right, let's put it all together. So we're going to expand this one now. So 1 plus 4x is in the denominator, so the power is minus 2. What is in the x position? The x position is 4x. What is in the n position? The n position is minus 2. When is it valid? I'm going to do that part straight away. So the absolute value of 4x is less than 1. So the absolute value of x is less than a quarter. Okay, quick mark to get here. For the rest of it, I do the expansion. So how many terms? Up to and including the x cubed term. So 1 plus nx plus n times n minus 1. Yeah, you sort of get the idea. So I'm going to do 1 plus n is going to be minus 2. So I'm going to do minus 2. I'm going to times it by the x. The x is going to be 4x. Okay, so what's this whole thing going to be? This is going to be minus 8x, isn't it? Okay, I'm just doing this in the interest of time, but normally I would write this all out. Okay, I would normally write all of this stuff out. We're going to have n as minus 2. Minus 2 times minus 3 is going to be 6. 6 divided by 2 is going to be 3. Okay, the x squared term, 4x all squared is 16x squared. So what am I going to get there? 16, 32, I'm going to get 48x squared. Okay, and so on. 30 seconds. Can I do the last one here? So minus 2, minus 3, minus 4, what's that? It's going to be 12, it's going to be minus 24, over 3 factorial, which is 6, so that's going to be minus 4 from that part there. This is going to be 64x squared. Okay, so this is going to be minus 108, minus 256, okay, x cubed. You wouldn't do it as quickly as that, but I have a time limit on recording the videos. So the expansion is valid as before. Okay, and make sure we use the formula, substitute things in. Don't forget to follow the usual steps.